Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of some important questions of kinematics of constant acceleration. For this lecture, I am using the work of one of my best students, Ms. Fatma Shah of class 2022, the Lyceum. An important advice for me and for everyone: we must be sincere to others. This question is very simple. This is the diagram. This is the velocity time graph for the motion of a machine's cutting tool. The graph consists of 5 straight line segments, 1, 2, 3, 4, 5. The tool moves forward for 8 seconds. This means this motion, 8 seconds. While cutting, and then takes 3 seconds to return to its starting point. And this means this motion. That means both the areas are same. Moves forward and return to its starting point. Now, the first part of this question, we need acceleration of the tool during the first 2 seconds of its motion. For that, we need to use gradient. Use gradient formula and get this acceleration, which is 0.09. The distance the tool moves forward while cutting, we need this area. For that, we need to use area of trapezium. Area of trapezium is half height into sum of these two times. This is 4 and this is 8. So this area is 1.08 and this area is also 1.08. Now we need greatest speed of the tool during the return to the starting position. This is speed. So we have area, we can use area formula and we can get this speed. This is here. The greatest speed is 0.72. You can check this solution again. Sorry. This question is very important. Particles P and Q are projected vertically upwards from different points on horizontal ground with initial velocities 20 and 25 respectively. Now this is very important. Q is projected 0.4 seconds later than P. I discussed this concept in my first lecture of important concepts of kinematics in detail. Since Q is projected 0.4 seconds later than P, therefore time of Q will be time of P minus 0.4 when both particles meet. So, if time of P is T, then this is the equation of time of second particle Q, T minus 0.4, where T means time of P. Part 1. The time for which P's height above the ground is greater than 15. This is very simple. You just need to use this equation of motion. ut plus half gt square with g minus 10. So when you will substitute minus 10 into that equation, you will get ut minus 5t square greater than 15. When you will solve this inequality, you will get two values of t, 1 and 3, and the answer is 2 because we need time when the particle's height is greater than 15. This time. So over here t is 1 and over here t is 3. So this total time is 3 minus 1, which is 2. And when you divide this time by 2, you will get this time. So this is 1 and this is 1. But we need total time, which is 2. Now, we need velocities of both the particles at the instant when particles are at the same height. Same height means height of P is equal to height of Q. But for Q, we will use this equation. This is the time of Q. This is here, height of P, so ut minus 5t square, and height of Q. For Q, you should use this equation. Write time of Q here, and time of P here. Time of P is P, C, and time of Q is t minus 0.4. Make sure you substitute t minus 0.4 here and here. When you solve this equation, you will get the value of t when the particles are at the same height. Now you just need to get the time of q first. This is time of p, and q is projected 0.4 seconds later than p. So time of q must be 0.8. 1.2 minus 0.4 according to this equation is 0.8. Now you can easily get the velocities of both the particles because we have the times of both the particles. So with the help of this equation we can get velocity of p, which is 8, and with the help of this equation we can get velocity of q, which is 17. The most important part of this question is this equation. Make sure you must be good at this concept. This is the next question. Two particles P and Q are projected vertically upwards from horizontal ground at the same instant. The speeds of projection of P and Q are 12 and 7. This has 12 and this has 7 meters per second initial velocities. And the heights of P and Q above the ground, T second projection, HP and HQ. Each particle comes to rest on returning to the ground. Find the set of values of T for which the particles are traveling in opposite directions. For this thing, are traveling in opposite direction, you just need to get the time of both the particle at their maximum height. So first get time of P when it is on its maximum height, at its maximum height, and then time of Q. I told you we use this equation, u upon 10, for time to reach the particle at its maximum height. You can also use this equation, u plus gt. But I discussed this equation in my first lecture. So time of P, 12 upon 10, 1.2 seconds. So when P is here, its time is 1.2. And when Q is here, at its maximum height, its time is 0.7. So after 0.7, Q was moving in this direction and P was moving here. So 0.7 and 1.2, for this interval, both particles were moving in opposite direction. This was moving here. After 0.7, Q was moving in this direction and P was moving here. So the answer is T lies between 0.7 and 1.2. So this is the way to find the values of T when particles are moving in opposite direction. At a certain instant, P and Q are above the ground, and find the velocities of P and Q. So with the help of this equation, we will first find the value of T, and then we can easily find the velocities of both the particles. We just need to use this equation. So the equation is 3hp 8hq. So we just need to put, we need to use this equation, ut plus half gt square. We have u, we have g minus 10. We can easily get the value of t. Now we just need to put this value into this equation and this equation. So velocity of p is 4 and it was moving in upward direction, and it's minus 1, that means it's moving in downward direction. And this shows after 0.7, when t is greater than 0.7, both particles are moving in opposite direction. You can check this solution again if you want. Well, I have to leave for Juma prayer. Unfortunately, I don't have time to discuss the other questions. So this is all. I hope this lecture will help you to understand how to solve the questions of kinematics, of constant acceleration. I will discuss the leftover questions of this topic in my next lecture, inshallah. Good luck to everyone, and I'm extremely thankful to Ms. Fatma Shah who helped me to make this lecture. May Allah Pak bless her with great success. Ameen. Allah Hafiz.